Hi, my name is Eric Law. I built a system to control a beverage fermenting. So what I call this is a temperature regulating system for beverage fermentation. What this is designed to do is to keep the liquid inside of this vessel at a constant temperature that's defined by the user at the start of the program. So basic operation works by you start up the program. You can use these buttons to either raise or lower your target temperature. Then you start the and you can also actually set a defined amount of period you want the system to run. So you can say you want this system to run for 7 days at this temperature. Once it reaches 7 days, it will actually shut itself off and put the device into the sleep mode, which is a lower power consumption mode. So the basic idea is this microcontroller is interfaced to a temperature sensor. The microcontroller then reads the temperature, compares it to the user-defined value. If it's below, if the read temperature is below the user-defined value, it will turn on this heating element to ensure that you can actually raise the temperature. And then after that, it waits for about a minute, resamples the temperature. If the temperature is above, it shuts off the element, above or equal to, I'm sorry. It shuts off the element and waits another minute and does resampling. This happens again and again until the fermentation period has been reached. So one of the biggest issues I had with this system was actually creating an accurate timer on here. So I'm using the internal oscillator to actually keep track of time. I wanted to make sure that I could actually keep track of an hour accurately without too many seconds over or below. So we could actually keep track of, because that actually propagate over, many days, and you can get an inaccurate reading over, say, 2 weeks or something like that. An inaccurate 5-second timer can really lead to, maybe an hour or two off, which may be undesirable for some. One of the biggest motivations behind this project is creating a consistent product or a consistent beer or wine, which is really difficult for many home brewers. And that by regulating the temperature, you can actually ensure that your yeast are actually not stressed, because large fluctuations in temperature can stress your yeast and produce off flavors in your end product. The other thing I ran into was ensuring that this device didn't oscillate too much, so I wanted to make sure that it wouldn't turn on the heater, turn off the heater, every second or 5 seconds or whatever, to ensure that, electronics don't get damaged from quick switching and that you don't get stuck inside some weird oscillations that could, be detrimental actually to this, raising the temperature. You might take a sample in between and it could lead to some inaccuracies. So by waiting, say, a minute, it allows the residual heat inside this heating element to actually diffuse all the way into the liquid. So that was one thing I kind of ran into and found that this vessel is a little bit too small, so this is really more of a prototype. It'd be better to actually scale this up to a 5-gallon batch so you can ensure that you don't actually raise the temperature too much in between your samples. One other issue I ran into too was this heating element actually runs off a 120 volt AC wall outlet. It's a 20 watt heater, so it doesn't draw too significant amount of current for a heating element, but it was still too much for this microcontroller to handle, obviously. This can't output an AC 120 volt signal at a substantial amount of current, so that's what this device is here for. This device is essentially my heater driver. What I do is I send out one bit to this guy to tell it to turn on. It activates the relay circuit and actually closes the circuit between the wall line and the heating line. If you guys wanted to take a look here, you could actually play with the user interface. You can play with it and actually run the program here if you guys wanted to take a look. So another really great thing about this is a product that was not actually available in the marketplace already. So this was actually something that homebrewers haven't had before, and it's actually going to, you know, hopefully be something that a lot of people would really enjoy having to produce. You know, say you make a recipe you really like and want to reproduce it again. With this system, you have better chances of reproducing the exact same recipe you did before. So yeah, you guys come on over and take a look at this. Take a look at it. It's pretty easy to use. The temperature that you want to set is controlled here, up or down. The days you want to leave it on is up or down here. So what we'll do is we'll put it in reset mode so you can actually do user-defined. When it blinks like this, it's waiting for user-defined input. So if you want to go ahead and try it out, you can actually see the current temperature readout coming from this temperature sensor here. And
does it change on here?
Yeah, so what you have to do is you actually have to hold this down. It's kind of like a clock radio. So you gotta hold it down. What we'll do just for an example here is we'll pick a target temperature that's actually above the reading temperature so we can turn this element on and actually see that this is an actual functioning system. And if we have enough time here, you can actually see it turn off as well. So once if you guys come closer here, you can look. Once you've defined your values you want, you simply just push this toggle switch over, go to run, and now it's running. As you can see, this takes a couple seconds to refresh because I'm using a very slow clock. That's for less power consumption and to actually try to make a timer using the internal clock that's a significant amount of time. I use a 5-second timer, which is, you know, it's a significantly larger than an internal clock runs at. Right now I'm running at a 250 kilohertz oscillator, so I had to actually do a counter in there to actually make a 5-second counter. So that's one of the reasons I have a slower timer. So as you can see, it refreshes the LED. It takes about 7 seconds to do a refresh to actually sample the specimen and then do the AD conversion and refresh the OLED on that slower timer. But even though it's running slower, it's okay because this is a system that you're just supposed to put in your closet and forget about it. So, and it's also lower power consumption, so you don't run out of battery. So yeah, if you guys come close, you can actually feel that the heating element actually turned on because we wanted a temperature that's higher than the current temperature. So after a couple, it's actually also another feature of this is that it will only turn the heating element on or off every 1 minute. So even if it gets to temperature, it's going to wait a minute, keeps track of a minute, and turns it off so you don't get weird oscillations like I was talking about. Are there any questions you guys have on this?
So you have to reset it to change the temperature and the day?
Yeah, so that is correct. It's not, you can't update the program on the fly. You could do that. I just figured, you know, the reason I didn't do that is because I actually have a faster clock period when you're defining the values, or I'm sorry, clock speed. When you're defining the values, that's why it doesn't take a long time to refresh it. So actually do change my oscillator when you go into the actual run the program mode.
What exactly is displayed?
So your current temperature, your target temperature, your current lapse time that the system's been running, and the user-defined amount of time in days is displayed.
So what happens when it reaches its time limit?
So when it reaches its time limit, it actually, as for a safety precaution, this turns the heating element off, regardless if it's on or off. Just double checks it, and it actually puts the microcontroller into a sleep mode, which is a lower power consumption mode. Obviously, it's not completely off, but it's still not using too much power. It's about half as much as it usually is.
So you didn't end up needing a watch?
No, I didn't. I was able to use everything on board on there. A real-time clock chip would have been nice, you know, to actually have a nice timestamp on it, but it wasn't a required piece of hardware.
How long can the microcontroller run off a 9-volt?
So from my preliminary, I haven't actually tried to max it out yet, but from my preliminary calculations, it's 2 weeks. And so that's actually one of my one of my limitations
Yeah.
on this system. So it actually can only operate, the liquid can only be run in operation between 40 degrees Fahrenheit and 90 degrees Fahrenheit. This is due to restrictions on this thermistor. It's only linear in that region. You kind of start getting a little bit unlinear parts of it. And it's just, if you wanted to extend it, you'd have to write a little more software to actually control that unlinear part of the, I guess, oh, there you go, you hear it just turned off. So it reached this temperature and now it turned off. Sorry, I just lost what I was.
So the 2x is with the sleeping mode in place?
Yes.
So does it go to sleep while it's regulating?
No, it doesn't. That would be one thing I would like to implement. I didn't implement a watchdog timer on this, which actually puts the primary oscillator to sleep and generates an external event to actually wake this thing back up. That's just something I didn't have time to implement because I was a little unfamiliar with it at the time.
So if you're sampling at, say, 1 minute, you could go to sleep between that 1 minute and then wake back up in a minute and check.
Yeah, you could do that. You'd need a slower. The thing about that is you'd need some kind of event to tell it to turn back on. And a minute's kind of a long time for any oscillator. I don't know if any oscillators are minute oscillators. I'm sure they're out there, or that generates an event every minute. That would actually something that generated a minute event would be great.
So it might require like a real-time clock, external device or something.
Yeah, or just maybe it would be cool as an alarm clock. So every time the digits updated, it would actually send a pulse to this, something like that. Some, maybe a little hack like that.
That'd be cool.
Okay, thank you.